Welcome back, focused learners, to another explainer. I am absolutely thrilled you're here today because honestly, we're tackling a topic that is practically a real-world superpower, data handling. We are going to break down exactly how to capture, organize, and really understand information in a structured way, making every single concept crystal clear.
Okay, let's dive into this. Have you ever looked around a totally packed room and just thought, how on earth do I find out what everyone here is actually thinking? I mean, imagine the absolute chaos of trying to read the minds of dozens of students all at once. Everyone has different opinions, different tastes, and totally different ideas. How do you take a room full of random thoughts and turn them into neat, understandable facts? Well, that is exactly the puzzle we are solving today.
Section 1. The Big Question. Discovering Class Favorites.
Let's meet two of our incredibly curious students. First up, we have Rohan. Now, Rohan is a huge fan of mathematics and arts. He really enjoys reading about the environment and playing sports. But then you have Anjali. Her tastes are entirely different. She absolutely loves languages and gets a real kick out of listening to and reading stories. Because they have such wildly different interests, it naturally sparks the question for them, if we are this different, what is the rest of the class actually like?
And that curiosity leads to a real defining moment. They essentially say, hey, let's actually find out from our class which subject they like the most. This quote right here is the exact starting point of their data journey. They're shifting from just kind of wondering about their classmates to actively planning a real, concrete data collection project. They have a goal now, but how do they get there?
Moving right along to Section 2, formulating the right survey. Because as we know, before you can collect any data, you really have to ask the right thing.
So, Rohan and Anjali brainstormed and they ended up settling on a clear winning question. Which subjects do you like? It's direct, it's super easy to understand, and honestly, it's the most appropriate way to find the most liked subject. It lets their classmates quickly categorize their thoughts and give answers that our two researchers can actually use.
And this brilliantly illustrates exactly what happens when you ask a good, clear question. Just look at that. Every single hand shoots straight up. When you're clear, people are eager to answer. But take a second to consider the sheer scale of the data being collected here. All those eager students, all those overlapping answers just floating around the room. It's exciting, sure, but it's also incredibly overwhelming. How do you even begin to keep track of all this?
Section 3. Recording the class data.
Well, the answer is creating a system. They came up with this really clever shorthand strategy. Writing out the world around us or physical education dozens of times? Yeah, no thank you. That would literally take forever. So instead, they just assigned single letters to represent the data. M for mathematics, L for languages, T for the world around us, A for arts, and PE for physical education. This kind of simple data coding makes the actual recording fast, super efficient, and honestly, way less prone to mistakes.
So I want to ask you directly, if you were standing at the front of that room, how would you manage tracking all those voices? You'd probably want something exactly like this setup. Armed with just a simple clipboard, their new shorthand codes, and a clean sheet of paper, they're totally ready to turn those chaotic shouts into organized, usable lines of data.
And guess what? It worked perfectly. They successfully recorded a massive 45 individual student responses. 45! By just taking a minute to create a structured plan, what started out as a really noisy room full of opinions suddenly became 45 neatly categorized pieces of data.
Section 4. Categorizing word problems.
Now, what's really interesting about this slide is the core idea that mathematical word problems are honestly just different ways of hiding a missing piece of data. Solving them is entirely about pattern recognition. You really just need to figure out one thing. Where does the question mark actually go in the story? Once you see that pattern, the whole thing becomes incredibly straightforward. Let's break down the first two major patterns. First, we have combined problems. This is literally just two different sets being added together. For example, if there are 343 kids in one stage of school and 532 in another, what's the total? The math is simply 343 plus 532 equals our unknown, our question mark. But then look at change problems. This is when an existing set actually increases over time. Say I have 445 in the bank, and later I check and I have 800. How much did it go up? Now the equation is 445 plus our unknown question mark equals 800. Do you see how the unknown variable just shifted its location? The structure of the real-world data completely changes the math equation. Let's look at two more variations really quick. First, another type of change problem, but this time we're trying to find the initial amount.
Let's say a shopkeeper buys 150 more kilograms of potatoes and now has a total of 500. How many did he start with? Here, our question mark is right at the very beginning. Unknown plus 150 equals 500. Now contrast that with compare problems. In these, we're comparing two totally distinct quantities. For example, Anu is 8 years old, and she is 6 years older than her sister Minnie. So how old is Minnie? The equation becomes 8 equals the unknown question mark plus 6. Recognizing whether the data is combining, changing, or comparing, that is absolutely the key to finding your answer.
Section 5. Comparing mathematical scenarios.
So, the crucial point is this mental checklist. Whenever you face a data-driven word problem, just briskly walk through these 3 steps. Step 1. Are you taking two totally different sets and putting them together? If yes, boom, it's a combined problem. Step 2. Is there an existing quantity that's growing or shrinking over time? If so, it's a change problem. And step 3. Are you looking at two distinct quantities side by side just to see the difference between them? Then you've got a compare problem. Master this little checklist, and I promise you can solve any scenario thrown your way.
We have honestly covered so much ground today, from Rohan and Anjali organizing a chaotic classroom with some clever shorthand to completely breaking down the hidden math inside word problems. And it really all comes back to how we handle information in our everyday lives. So, I want to leave you with this final provocative thought. If you were to survey your friends today, right now, what data would you be curious enough to collect? And more importantly, using exactly what we've learned, how would you structure and record it? Think about it. Keep organizing your world, keep asking those great questions, and I will see you in the next explainer.